Hi, everybody. I'm Jared. I'm a PhD student here in physics at OSU, and we're here to have some fun with shapes today. And what we mean by that is we're going to be teaching you about a branch of math called topology. So topology, like I said, deals with qualitatively describing shapes and whether or not two shapes are the same. And so there are some rules in topology that we can do. Is we like to pretend that all shapes are made out of Play-Doh, so we can easily mold them to be whatever shape that we want them to be. But we can't cut shapes in half, we can't glue two different shapes together, and we can't punch holes in shapes. So using these rules, can I mold this egg into this container? Or can I mold the egg into this coffee cup? So the answers to these questions is that I can mold this egg into the container, so they are topologically the same, but I cannot mold the egg into the coffee cup because that would require me punching a hole in it, which is not allowed. So today we're going to be doing some experiments with pieces of paper that explore this idea of topology. So the question that I want to ask is, can we get this bird to get to this bug on the other side of the paper? And can the bird do that in a straight line without going off of the page and obeying all the rules of topology? So my good friend, Dr. Liu here, he's going to give that a try.
Hi, everyone. So as Jared said, our goal is actually just to draw a line between the bird, a straight line between the bird and the bug, so that the bird can actually follow the straight line and get the bug. So now what I'm going to do is to give it a try. And the way to do it for me is that since now you can see the piece of paper has two ends, what I'm going to do is I'm going to glue the two ends together. I hope, gluing them together would allow the bird to actually touch the bug. So now I'm first going to glue this end via tape. Okay, now the whole thing is glued together. The next thing I'm going to do is I'm going to start to draw a line, starting from the bird. Yes, now the bird is going to follow the line. Try to get to the bug. And this line keeps going and going along the middle of this strip, passing through the tapes. And keeps going. And oops, it goes back to the bird. So unfortunately, this strategy doesn't seem to work, right? You can see we draw a line starting from the bird, and no matter how long we go, in the end, we just stops and come back at the same point. So unfortunately, the bird doesn't really touch the bug. You can see the bug is still alive there on the other side of this tape. However, the bird is on this side, and this side, the bird can never touch the bug on the other side. So unfortunately, I failed. So how should I do to connect these two things together? Do you have any idea, Jared?
So I think I have a clever solution to this problem. And so we're going to start the way that Dr. Liu started, and we're going to start folding this piece of paper like this. But what I'm going to do differently is I'm going to twist this end and then connect it like this. So I've twisted one end of the paper 180 degrees, and now I'm going to glue it together with some paper. Together.
This shape is real harder to.
Yeah, this shape is a little harder to tape together, but you can do it with some effort. So now let's see if we can draw the line from our bird all the way to our bug, which is located here, right? So we're just going to draw that straight line, similar, exactly the same as how Dr. Liu started drawing his. And because this shape is a little harder, it might take you guys a little longer to draw the shape, but that's perfectly okay. Take your time and just do your best, like how I'm doing. So what I do find is that by adding this twist, the bird can follow this line all the way to the other side of the paper and get to the bug. So yeah, the bird can do that. So these two shapes, this cylinder, what we call a cylinder, and this Mobius strip are topologically different from each other because the bird on the cylinder is unable to get to the bug on the other side of the page, but it can do that on this Mobius strip.
In other words, the cylinder has two sides, two surfaces which are not connected to each other. On the other hand, the Mobius strip has only one surface.
Yeah. So now what will happen if we decide to cut along this line that we just drew on this paper? What kind of shapes are we going to get if we decide to, cut these two shapes in half? So why don't we do that?
Let's cut just along the line we just drew earlier. I'm going to cut the whole shape in half. As you can see, the Jared's line is a little longer than mine, so it takes a little longer for him to cut them. Yeah.
But
now at
the end of the day, once we're all cut, my shape has stayed intact. I still only have one loop, but Dr. Liu, he has two.
Yes.
Right?
In the case of cylinder, if you cut them in half, it breaks into two cylinders. On the other hand, for Mobius strip, you cut them in half, it's still unconnected ring. Yeah. So that just shows you how different these two shapes are. It's by cutting them in the middle. Yeah. We hope that this little exercise tells you some basic idea about topology and how different shapes can behave once we cut them through. So if you feel interested about this stuff we've been talking about, we want to actually give you two take-home exercises. So the first one is still about Mobius strip. So remember, in the case of Mobius strip, what Gary did is that you twist the end of a cylinder and then you glue them together, right, like this. Then you form this Mobius strip. As you can see, Mobius strip only have one surface, as we have said earlier. So now let me glue them together, as Jerry did before. So now we get this shape, which we call Mobius strip. This weird shape. Okay, so now the take-home question I want to ask you is, earlier we cut the whole shape in half in the sense that we just draw one line, which is along the middle of this whole shape, right? Now, what if we draw two lines rather than one line?
So we draw two lines like this on the piece of paper instead of just one line down the middle.
Yes. So if we draw two lines on this Mobius strip, what would it look like? Would you be able to connect the starting point and the ending point together, just as we did earlier? And also, what's going to happen if you now cut along these two lines we have drawn? Will the whole thing still be one ring connected together like this? Or it will be something more interesting? Yeah, so that's something we encourage you to try in your free time.
Another take-home exercise that you can do, instead of just creating a simple Mobius strip by doing one twist, what happens if you decide to twist twice and then glue it together? Can the bird still get to the bug if you twist the paper twice before connecting it?
So we hope you you find these exercises intriguing and get some time to try it yourself. So together with this video, I also made some slides with some supplemental information. So in the slides, you can find, for example, the shapes we have shown you today. And also, you can find some interesting YouTube video, which have very nice animation about these different shapes like cylinder, Mobius strip, and even the more twisted shape that Jared asked you in the end. So we hope you find this class interesting, and we hope this somehow opens the door for you to explore some interesting facts about topology. Yeah. All right. Thanks for your attention. Yeah. Take care, everyone.
Bye, everybody.
Bye-bye.